Hello, everyone. Thank you for joining us this evening or day, depending on where you are. And welcome. Today, we're going to be talking about going from documents to insights. And I'm going to be joined by Utsav. I'm going to add him to the stage, who joins us from Mongo. And we're going to be talking about a project that we built together. Let me quickly introduce us. I'm Tuana. I work in developer relations at LlamaIndex. Utsav, maybe you'd like to introduce yourself.
Sure, thank you. Hello, everybody. I'm Utsa Talwar, joining in from MongoDB. Stoked to be here, and we'll take this discussion forward.
All right. With that, I am going to do a quick introduction into how this session is going to run. I have a very small part in this whole session because honestly, a lot of the work was done by Utsav, so it's only fair that he gets to present his work. What we'll be doing is I'll give a quick introduction into what we're going to be talking about, the various LlamaIndex technologies we're going to be talking about, why we're even doing this session. And then we will also be monitoring the comments to see if you have any questions. We also have one of my colleagues, Murtaza, in the backstage. Myself and Murtaza will do our best to answer your questions as we're going. But if there's anything that we'd like to answer live, we'll do that at the end. So please keep the questions coming. And if you have any questions for Utsav, we'll also try to make sure that we deliver those at the end of his session. And we'll get your question up on the screen and hopefully we'll get through everything. All right, so why are we doing this session? Well, we recently built a demo together with Utsav and a couple of his colleagues. You can use that QR code on the top left to see what the demo was all about. But all in all, we built a document processing pipeline that uses LlamaParse, which is the Llama Cloud parsing tool. I'm going to go through that very briefly in a bit as well as MongoDB. And our aim here was to really build a pipeline, a workflow that is able to deal with the types of documents and files that we encounter in day-to-day life, work, that have a lot of moving parts that we have to deal with when it comes to building AI agents. And in this respect, we're talking about documents that have various layouts, tables, images, and we really need to make sure that any AI agent we're building is able to handle that information that is additional context to an AI agent. So before we dive into how this whole pipeline was built, the challenges that mainly Utsav faced, I want to give a quick introduction into all of the various LlamaIndex technology that you're going to be hearing about during this webinar. So we really have two groups of products at LlamaIndex. And the bulk of the products we're going to be using is what you see in the bottom layer here, which comes with our cloud offering called Llama Cloud, which has a few document parsing and processing tools that range from tools that allow you to do structured extraction as well as parsing. We get lots of questions about the difference between extraction and parsing. If you would like to, feel free to ask again, and I'm happy to give an explanation at the end. But we also have tools that allow us to index and retrieve large amounts of data, as well as classification and your usual data connectors. And a bunch of these were used in collaboration to build the final demo. The second group of products is really our open source offering. And here we're talking about the LlamaIndex framework, Llama agents, agent workflows, which really are developer tools for you to design, orchestrate, and build out your own agents. And often here we're talking about task-specific agents. So a quick intro into LlamaParse. You can think of LlamaParse as a agentic parsing tool, and it really is there to serve for one particular problem that we face very often, especially when we're building AI agents that are supposed to work with real-world data. And it boils down to the simple fact that real world data is messy. It often comes in file types that are difficult to parse, that also may have inconsistent layouts. So here you can think about PDFs with irregular layout, maybe invoices, SEC filings, and similar. Maybe also files that include images and graphics that add additional context as to what the actual document is talking about. So LlamaParse is our cloud tool, which you can configure in various ways to be able to parse the content of files and put it into a format that is easily digestible, if you will, for large language models. And when we say easily digestible, we're talking about formats that are maybe pure markdown that inherently embed layout information. We're talking about simple TXT, JSON, etc. Another set of tools is LlamaExtract, which we're not going to go super deep into today, but is in a way similar to parsing, but it is for a different purpose. So LlamaExtract allows you to define a schema that you can use as a way to extract the targeted information that you're after in your document. So in this case, you can think of, for example, you have an invoice in front of you, and that invoice may have only a few fields that is relevant or useful for your downstream tasks. For example, you just need the date and you need the amount, for example. So you can define these in your schema and get LlamaExtract to extract only that information from your document. We recently also added citation and reasoning to LlamaExtract, which allows you to make sure that what has been extracted is what you expect to have been extracted, and it allows you to just check that everything is accurate. And finally, we have Llama agents and LlamaIndex, which is a way for you to curate your own agent workflows, define the exact decision steps that this agent is able to make, but we won't be really covering this too much today. And with that, I'm going to be handing off to Utsav to talk about the final product that we built. So Utsav, let me remove my screen and add yours, and the stage is yours.
Thank you. Thank you so much, Joanna. So let's begin. I think that was a very great introduction given by Joanna. Um, that talks about LlamaIndex. We will focus more on the MongoDB side here, me being from Mongo itself. So that's the agenda for today. I just wanted to highlight what you will be getting out of this session. So we'll try to understand the problem space first. We'll try to understand what was the issue that we were facing and why we tried to build out this complete pipeline. Secondly, we'll talk about how LlamaParse and MongoDB will fit in together and how they're working together as a team. Step-by-step architecture will also give you an overview, a bird's eye view, exactly of how these things were fit in together to build out kind of a demo. That's the next part. And at the end, or in the meantime, while I'm talking about the complete solution, you can add your questions and we can talk about it as well. So let's start with the RAG. I think most of us know what RAG is. That's the baseline of the complete architecture. That's the baseline of the complete solution, actually. So just to give you a very brief introduction about RAG, if somebody is not aware about it, it's basically if you have been using ChatGPT in some sense, you might have uploaded your PDF files and uh, might have asked a few questions on top of it, right? Like you uploaded your document, asked it to summarize it. You might have asked it to fetch relevant information from the document and so on and so forth. So that is like the base version of RAG. But when we talk a bit more on that, when we talk about at the enterprise level exactly, we are ingesting a bunch of PDF files. We have been ingesting a lot of data that is company centric and that is very confidential in nature. And that is something that we are trying to train our LLM models on, or rather give them the context. Like this is the data that you should refer for answering any kind of question that a query might get popped up on. So that is what is happening. You have the unstructured data. and the unstructured data is getting converted into a format that is more understandable by the computer now. That is the embeddings, right? Sitting in between is the embedding model, and there are a bunch of embedding models that are in the market right now. MongoDB also has acquired a company called Voyage AI recently, and they also provide, they're kind of a leader in providing the embedding models and the re-rankers as well. So again, a bunch of different models, a bunch of different technologies are available, and a lot of companies are working on this specific problem, which is the embedding model problem, to convert their PDF files, to convert images, audio, whatever that you can think of, to embeddings, right? So that is what gives a structured approach to unstructured data. But the challenge comes here is, when we have uh, not just one PDF that we are uploading to ChatGPT, but we have a lot of PDF files. We might even have some kind of um, text extract. We might have some kind of screenshots or whatnot. So these kind of things can be available uh, in an enterprise, and this is something that we are targeting at, right? So PDF files might not always have a structured form of data. They can include, you can say, graphs, they can include charts, they can include screenshots, whatever. Right? There are a lot of things that are available in a PDF file, and that's not always straightforward. So this is where the normal text extraction would fail. This is where, if you want to just extract the PDF from using a Python library, that will just fail, right? Because the complete end-to-end life cycle of extracting and making it accessible to the users, it's very complex, right? You will have to extract the data first of all, and the text extraction should be in such a way that it makes sense to the database. It makes sense to it basically gives context to the LLM. It should always be able to extract the PDF files with the relevant metadata, like giving the page number, the author, the details about specific diagram and whatnot. So all of that data needs to be extracted. Then the next part comes in where you want to clean and store that data. That storage should be in such a way that it is able to extract the relevant documents very fast, and the document should be reliable. Like, it should not be giving irrelevant documents back to the LLM, let's say. And because if the context is not rightly set to the LLM, it will just not give you the right responses back, however great your prompt might be, right? So that is the complete challenge that we faced, and there were a few customers that were asking for this complete pipeline, how we can um, build this pipeline so that the data that is sitting in an S3 bucket somewhere, how we can make that insightful, how we can ask questions to it, so we can make some kind of a chatbot that can fetch relevant data from that S3 files, right? So this is where the combination began. This is where LlamaIndex got introduced, and LlamaIndex is actually a partner, a tech partner with us, with Mongo, and we have been collaborating with a few initiatives. We have been collaborating with a few partners and clients to help them implement a joint solution, and this is just one of the ways that you can implement it as well, right? So I'll just want to give you a brief about LlamaIndex. I guess a lot has been covered already by Tuana earlier in the session, but it's basically why we use LlamaIndex was how efficient it gives the result back for any PDF files that you upload. It understands the structure first of all, and it will extract the page with its complete schema and with its complete structure. So that was very relevant to us. That is one of the reasons why we chose LlamaIndex in this complete scenario. Let's talk about MongoDB. Let's talk about why MongoDB actually fits in into this GenAI based application. And if people are not really aware about what is Mongo, it's a database wherein it's a NoSQL database wherein you have a lot of data which might have already been spread into different tables. If you are familiar with relational database, in Mongo, the data is it's kind of stored into just one single document, right? Rather than splitting it into different tables, as you can see here, it's kind of condensed into one single document, and that is the best practice. that is not just you are extracting data and putting it or dumping it into one place. It's the best practice how you can extract the data when you want to query that data. So for example, if you want to extract it using just one underscore id, you can refer it, or you can just refer using the first name or last name, and you will get the complete detail of that single of that person basically. So you can query on top of it. And on top of the data model, the flexible data model, we offer the adaptability, we offer the changeability of the complete document at runtime. So whenever you want to make changes to the complete document, or you want to add a field, remove a field, you can do it without even doing any kind of migrations or anything like that, right? You can just log into the console, add extra field to it, and the complete application itself will take care of it. You don't have to make any changes to any kind of tables or etc, right? So that has been an intro, I guess, about a good intro about what is Mongo and what is LlamaIndex. Now let's talk about the complete architecture that we were able to build together. It's kind of condensed architecture, and uh, this is kind of a beauty about how we were able to do multiple things, lot of complex things um, into just a few pieces. Rather than the complete pipeline that I was showing earlier, this is the condensed version of it, and a better and scalable version of it as well. Now consider there are again a bunch of different types of PDFs, docs, screenshots, whatever that you can think of, and it's already stored in your S3 bucket. It can be any object storage, but in this case, we'll just consider S3 bucket for now. The LlamaParse uh, is able to gather that data on the go, and once it is able to connect to your S3 bucket, it will then be able to extract, using the various technologies Tuana already talked about. It is able to extract that data into uh, and create it into a meaningful JSON document, which is then being pushed to Mongo. Now the beauty here is, once the embeddings are generated, the metadata is generated, and the content of the PDF document is generated, you do not have to split it across different tools and different technologies. It's all stored in just one place, and even in just one single document, which will be in MongoDB. I'll show you how that is done in future slides also. But the idea here is you are storing all of the data that is being extracted about the PDF document of, let's consider it's just one page that you're extracting from. So all of that information is being stored in just one place in Mongo. Now, how you will query it, how you will search and retrieve that data, that's again very crucial. To handle this, we have dedicated search indexes that is built on Mongo. It's called vector index. We also have search indexes in parallel, so you can do kind of a hybrid search query as well. Or if you want to do search just based on the vectors, that is also possible. So that's how you search that data. And once you are able to retrieve the correct context, you can pass it to a LLM, and the LLM will able to take care of the rest. So you will get a meaningful insight out of it. Whatever questions that you were asking to your PDF, you will be able to get the relevant responses back. So let's jump to the live demo piece. Um, yes. So this is the Llama Cloud. This is, I hope this is visible. Yeah, so this is the Llama Cloud that we will be using to set this complete demo up. For the sake of time, I have already set an index, but we'll try to create a new one also to show you how that is done. Uh, First of all, as I mentioned in the let's go back to our reference architecture. We'll have an S3 bucket which will be connected to the LlamaParse. So that is what we are going to do here. I have already set my S3 bucket. And if I go to my S3 bucket here, I have just generated four different um, screenshots or four different invoices. It looks something like this. It's a company called the Unique Store, and there are a bunch of necklaces. I mean, a lot of things that are there, and that's the complete invoice that has been generated, right? And there are four relevant invoices accordingly. So this is what the data is in our S3 bucket. Now you can sync it every 6 hours, 12, 24 hours based on your preference, or just don't do it at all. Um, Then we will go to the data syncing part. How we want to sync that data, basically what will be the sync, where the data will be added to. In this case it will be Mongo. I have already configured MongoDB here, so you can just if I go to MongoDB Atlas here, you just need to consider the connection URI, which once you set that up, you will be able to get a URI string, how you are able to connect to MongoDB, the database name, the collection name. You need to also mention the vector index name. You can keep it vector index, that's the default one, but you can mention any other vector index name also. And then there is a full text index name as well. So these are the two things that you need to mention so that it is able to do hybrid search that I was talking about earlier, right? So that is how you set up MongoDB. As I've already set it up, I'll just use this. Now, next comes is the embedding model. Now, again, coming back to this, once the data is coming to LlamaIndex, it will be converting that data, whatever text extract it is able to pull out, it will be converting that piece into embeddings so that we can power our GenAI applications basically. So in this case, we'll be using, I've configured Bedrock here with Titan embeddings. So this is what again I'll use here. And there are again some other configurations that you can set it up. You can have auto or manual chunking strategies, and you can just deploy the index. As I have already deployed my index, I'll just go to that piece. And the idea here is whenever the data is added into S3 bucket, if the sync is on, it will be able to gather that data and it will be able to run the complete pipeline end to end. And at the end, it will be able to add the data to Mongo. Let's go to the data sources here. So if you see, it was able to fetch 4 files, the number of files which were available in my S3 bucket. It was able to fetch all of the files. And now if I look at the preview here, you will see this is the parsed file. It is able to understand. It was able to understand the complete table, first of all. Let it load. Yeah, it was able to understand the complete table, first of all, and then it was able to create the chunks also out of it. Now this is the complete parsed file, and this is the file or the data being used to create the chunks out of it, right? Now um, let's go to our MongoDB, and this is where the data is being stored. This is our compass. This is MongoDB compass tool, which is which basically lets you connect locally to your database, to your collections. So I have LlamaIndex loader collection, and I'm using content the database, wherein I have four different uh, four different documents of each of the PDF or each of the screenshots or each of the invoices that I was showing you earlier. Now, if you look at it, we are storing this. This is what I was talking about. We have the embeddings. These are the vector representations that we are using. These are the embeddings that we are storing along with the textual information that we have. So this is, if you remember, this is the data that was extracted um, from that invoice that we saw in the Llama portal itself. This is what was extracted, and the data itself got converted to embeddings also. And on top of that, we are also storing the metadata alongside it, right? So the I think there was some good metadata like uh, yeah, the page number, since it's just one page, it will be one, but you can have the page number, you can have the file name, a lot of things that will be useful when you're trying to build it at scale. And if you have PDF files, imagine of 500 or 600 pages, it will be best if you can show like this is the page number that I'm referring to and this is the response that the LLM is providing. So the metadata is very useful in that case. So as you can see, again, just pointing this out, like the embeddings, the context, the operational data that you will say, as well as the metadata, all of that will be stored together in just one single document. And it can be extracted to at least 16 MBs. That is the size of one single document in MongoDB. And I mean, to put it into perspective, 16 MBs is like adding the data of all adding the extract of complete Bible, that it can be stored in just one single document. So that's the power of Mongo, right? The next thing I want to show here is the indexes that we'll be using basically to basically search on top of our data, right? So there were two indexes that we had added into our Llama portal. The very first one was the vector index. This is what helps us in finding the relevant documents based on the embeddings. So we are mentioning the path embeddings. Embeddings being um, the let me show you. Embeddings is basically the field name, and this is what it will be referring to. So this particular index, if I search using this index, it will be referring to the embedding path. Then I can mention the similarity, cosine, or there are two others that I can mention. And if I want to add some extra filters on top of it, that's called pre-filtering. So I can do that as well, and I'll be able to find the relevant documents back. The other part is you can also add a full text search. Now, if you see, this is full text search is basically added on top of all of our data. But in this case, it will be mostly used by the text that is here. So I can just query using full text search as well as the vector index, and then combine the results back using a RRF protocol, which is basically combining both of them to give the relevant responses back, right? So these are the two things. That's basically the highlight of it. And if I let's go back to our yeah to this to our presentation now, right? So basically, one question that might pop up in your head is why we are using MongoDB, and how is it better than any of other vector databases available in the market? So first of all, I am from Mongo. I'll have to talk about Mongo, but the truth there is it's a lot different. The use cases might be a bit different. Uh, Say for example, if you already have an operational database, say for example MySQL or Aurora or Postgres, whatever, you already have an operational database, but you want to add vector searching capability on top of it. How you will do it is that you might again go to some other tools like Pinecone, VV8, or any other popular vector embedding databases. Uh, they will be not they will not be working together with the operational database, but they will be an addition to your complete tech stack, right? And what happens here is you will have to do an ETL pipeline in between, wherein the data that is coming in your operational database will have to basically get converted to vectors. With the data will be extracted from operational database, it will be converted to vectors, and then it will be stored into the vector databases, right? And that's the complete orchestration layer that you will have to manage on your own. um, uh, Underneath, it's doing the ETL pipelines. That is, again, it might be very brittle, but again managed by the developers in your company. On the other hand, if you look at MongoDB, it will not require any ETL pipelines to run at your end, and it will be fully managed also. So what is happening here is, as I showed you, the vector embeddings as well as the operational data, it is stored basically together. So you do not have to do any ETL pipelines, first of all. And whenever you are querying your data, even using a full text search, like say you're just searching your name and you have a document that has your name with the embeddings, so you can just search using that, and you will be able to get the embeddings back as well as the complete operational data also back. So that basically skips the two hop process that you might be doing in your other tech stack, but it will be skipped completely in MongoDB. Now, this is, I think, I showed you how this is happening. You already had the context, you already had the operational data, first of all. Now, just adding one extra field to your complete data will give you access to building the GenAI applications, and it will be scalable as well. And I'm not just saying it, it's scalable. We have customer proof points. We have a customer who has developed a complete who has basically used MongoDB for storing 4 billion documents. Yeah, 4 billion documents, and they are running vector searches on top of it. And they have done some kind of optimization as well that I'll talk about. First of all, they have implemented it using uh, the vector the vector embeddings are being stored in Mongo with the operational data, as well as they also have binary and scalar uh, compression that is being applied on top of it as well. Right now, once that is done, once your data is stored in Mongo, you have the index definition that I guess I showed you. It's the paths, the vector embeddings that are being used here, the number of dimension and the similarity that you basically can pick up from one of these. And at the end, you're just making a query. You're filtering if there is any relevant data that you want to filter out. But this is what you are kind of doing to making the complete search end to end. So to put it all into perspective, why MongoDB fits in? Why is it? Why? What unique advantages it will provide you when compared to other relevant databases? First of all, again, I might be repeating it too many times, but the operational and vector databases is combined together in just one place, and that's very crucial. And that's something which is handled natively with Mongo. You will again have the vector searching capability, which is again native, and you do not have to rely on other tools, other practices to kind of build out a search index to kind of search the data on top of what you already have stored. And the scalability is coming from the search nodes, which can be deployed separately. Your vector embedding can be stored on those search nodes, so it can be less resource intensive and it can perform better in better at large scale deployments. So again, highlighting the complete blog post that we talked about, it includes a partner which is Confluent as well. Uh, in this case, we were trying to build out a pipeline uh, which is not batch based, like you saw in the Llama Cloud. It will sync every 6 to 12 hours, but in this case, this is kind of instantaneous. Like once the data is added into S3, you can access it using LlamaParse within that particular second, using that's all completely application based. How you want to trigger that, and it will be going through Confluent Cloud for scalability and other stuff, which is then getting added to Mongo. I won't go much into this blog, but you can read through it. You can understand what's happening in this case, and if you scroll to the end, you will also get the GitHub repo that you can go to and try to deploy it at your end as well. So that's what I had in mind. Um, I see there are a few questions that we can take. Over to you, Tuana.
Yes. All right. I think this means that we can move to Q&A, and we do have some questions. I've taken note of a few for you, Utsav, so maybe we can start from the top.
Okay.
I think this is for you at least. I think it came through when you were doing your presentation. What is the security for each user on the information?
Okay. So talking about the security, um, can we clarify on that a bit? I mean, for each user, is it the data that we are talking about, or how they're accessing the pipeline?
My understanding is there a way that we can set up separate things for each user so that, I don't know, if I've uploaded my own invoices, I'm not querying over someone else's invoices. How would you
Yeah.
handle that in MongoDB?
Yeah, I think in Mongo, it's basically you will have your complete database, your complete cluster. It's spread across. I mean, it's not spread across, but it will be different for each and every single user. We do not have access to your data. We cannot see your data, but it's just how the data is being stored. It's different for each user. If you create a cluster, if you want to deploy a database, if you want to basically deploy a cluster and create data into it, you can do it, and it's again very private to you. You will even have RBAC control over it, so you can manage it at that level as well.
We have a few more.
Okay.
Um, are vectors updated when the text is updated in MongoDB?
Okay, so that is not supported yet, but it might be coming soon. Right now, what you have to do is you can create that complete pipeline on your own. Once the data is updated, you will have to again map it to an embedding model, which will be updating basically the complete vectors. But that feature might be coming soon. No promises yet, but it might be coming soon in Mongo.
All right. So there is another question. I think this one is about LlamaParse. I can maybe talk about that a bit. What parsing configuration can you suggest for general parsing pipelines? Well, there is a basic parsing configuration. Let me actually check the exact name of it. I should probably know this off by heart, which should work for most simple parsing pipelines. However, we do notice that there are some situations where the file type that you're dealing with maybe has to handle more advanced layouts or differences in layouts. In this case, you might want to configure agentic parsing and maybe also pick the exact parsing model that you want to use accordingly. But for most things, I think if you're talking about very simple files that you want to parse, then the basic configuration is there for you. If not, you switch to the advanced tab, and then you can set basically everything up manually yourself as well. There was another question that I'm not going to put up on screen because it was pretty long, but I did share some resources that might be helpful. And basically the summary of it is the fact that you showed each invoice as one page, and what would we have to do if we want to handle both querying about the whole set of invoices and individual invoices in particular. And my general answer to this, maybe Utsav, you have another answer, but storing information that goes through semantic search or vector search, whatever you want to call it, this shouldn't matter whether you store individual invoices. On top of that, if you store individual invoices, you are also able to potentially do some metadata filtering before. So this means you both get access to the entirety of the data set, and you are able to answer questions, and the most relevant set of invoices are extracted initially. But you also get to ask individual questions. And before vector search happens, in this case, you do metadata filtering, filter down to the exact maybe user or the exact date or something like that. So this should work okay. I also saw does Llama Cloud support regular MongoDB also? Can Llama Cloud send to both MongoDB and another vector data? At the same time, I'm going to be honest, I don't know if we are able to send vectors to both MongoDB and another vector database. I think in this case, you may have to create a separate index. That is definitely possible because every index you can configure its own sync. Very good question on whether you can send both to MongoDB and another vector database with the same index. And right now we do support MongoDB Atlas. All right, I'm going to scroll down. If we have different layouts, this is again, I think, a question about LlamaParse. If I have different layouts for each PDF, what is the best strategy to deal with the data collection? This may require some level of context and or prompt engineering, but the main focus, I think, here would be to, even though there are different layouts, to focus on whether there is a unified theme. For example, are the different layouts because they're all invoices and each of those invoices are laid out differently? And we have some presets that are tuned to specific, let's call them thematic files and document types. So in this case, your parsing agent is able to deal with different layouts with a focus on a given theme. For example, an invoice or an SEC filing, etc. In this case, the different types of layout should be okay to handle, but the agent is configured to expect a certain type of data to be in the file that has different layouts. I hope this answers the question. I think this is a matter of trial and error as well. And you can also potentially define your own prompts to help the parsing agent figure out what the layout context even is in the first place. Let me have a quick look again. Remove this. Oh, I think this is for you. Do you ensure that the processing and store of the document is done in the same region as the S3 buckets? Do you have an answer for this, Utsav?
Oh, okay. Yeah, I mean, you can do that. I mean, if you're using now again, MongoDB Atlas can be deployed on any of the three cloud providers. So if you're extracting data from S3, you can put it into MongoDB, where it is deployed on GCP as well or Azure. So is there a reason why you're asking it? I mean, Isam, if you can highlight on that.
All right, I'll
I
keep
mean,
an eye.
basically, you can store that. You can keep both of them in the same region or a different region. But if it is a requirement from your side that it has to be in the same region, it can be. MongoDB Atlas supports 100 plus region across all the three cloud providers. So you can do that very easily.
All right, let's see if they expand, and I will at the same time maybe scroll up to see. I think this might be specifically about the demo that you showed. Maybe you can answer this based on what you implemented in the demo. There are different ways of handling new incoming data that has to be re-embedded, but let's take this question as for your demo specifically. Will the entire pipeline be rerun if new data is synced from S3? All the newly added documents alone get extracted, the updated embeddings, and then gets dynamically updated in MongoDB. I will quickly answer in terms of indexes in Llama Cloud. No, all of your pre-existing data will not have to go through the same pipeline again. We run the pipeline, or let's say we run indexing for the newly added documents, but I don't know how you implemented it, so I will let you answer as well.
So for S3 bucket, when you're trying to sync new data, it's again an application level question wherein you can configure it based on your needs. If you want your new data to be updated, your new S3 files needs to be updated with new embeddings, or the old files need to be updated with again new embeddings. That is both doable. But in our solution, what we have done here is when the new file is detected in S3, irrelevant if it was already there or not, it will always create a new document in Mongo. So that's what is implemented. But again, you can go back to it. You can make changes how you want to basically update the new files that is being added into Mongo.
And with that, I have run out of questions in the chat. I'm going to give it maybe another minute before we end the stream. If you do have any final questions, shoot them our way. And if not,
I say there is one question which was talking about MongoDB Atlas version needed for vectors. It's 5.0 and above, and right now you can do it in MongoDB Atlas, but in future we might give it for on-prem solutions as well. But for now, if you want to try it out, you go to MongoDB Atlas, create a free account, and start building out your vector embeddings.
there is one question that came up that I think I can answer if I understand this correctly. But I want to preface this by saying I'm not sure I understand exactly what you're asking. How do we prevent non-text document parsing? I don't understand what you mean for a long time, but is there a possibility to classify in the pipeline? I can maybe briefly answer this in terms of Llama Cloud. We didn't, apart from the initial introduction into Llama Cloud that I gave, we didn't really discuss it, but we recently released a Llama Classify tool in Llama Cloud, which is meant for exactly this type of situation, where initially you want to classify a document as one thing or the other. So that is definitely possible. And then depending on how it was classified or what label is given to a given document, you can either forward that to LlamaParse or not. And you can even use LlamaIndex workflows, agent workflows, to create that sort of decision flow. First using classifying the document as something you want to parse or not, and then using your exact parsing agent. Again, I'm not entirely sure if this is what you're trying to get to, but I hope that at least answers the question. All right. I think that's it, folks. Thank you very much for joining. Thank you, Utsav, for creating the demo and joining us for this webinar. And
Thank you
with
very much.
that, have a lovely rest of your evening or day to everyone who joined. Thanks, everyone.
See you.
Bye.
Bye.